Alrighty, so we got 2 more videos this time. I know I tried to make them shorter at least, but we have an extra topic at the end because hyperbolas is our last conic section. So I'll talk about that last topic here in a little bit. Well, actually in the next video. What we got to do for this one is we actually need to write the equation for the hyperbola. And there'll be 2 topics for this, so I'm actually going to go through the 2 different types, one of each. Okay, and so the first one, you're going to be given a foci, and those foci is -2, 8 and -2, 12. You will also be given vertices, okay, and so -2, 9 and -2, 11. All right, so like we've done with every other one, just sketch a picture. It makes your life that much easier. Okay, and so it'll give you lots of key information when you sketch it. So we're gonna go back 2 and up 8. So I'm just gonna 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we get back 2 and up 8. So that's one foci, and the other one is at 12. So 9, 10, 11, 12. So it's way up there. All right, so those are the foci, so they're actually not a part of the hyperbola, but these vertices are. So we're at -2, 9. Okay, so I know it's going to go that way around that foci, and I'm at -2, 11, so it'll go this way. Okay, so since everything's up and down, it's all in a line, I know I'm going up and down. Okay, and so what that means is the equation I have is the y minus k squared over b squared minus the x minus h squared over a squared equals 1. Okay, so the way I can tell this is that it's up and down. Okay, all the foci and vertices are up and down, and so I'm going to go ahead and think it's an up and down one. All right, so center here. Okay, center is going to be the dead middle, all right, between, you can do the vertices or the foci. The vertices are close together, so I'm going to take that into account. All right, so it's at 9 and 11. Wow, guys, should go back to 6th grade there. 9 and 11, 9 below, 11 above. Okay, and so what is the dead center between 9 and 11? Hopefully you know that. That is 10. All right, I'm still going back the -2 each time. All right, so my center is going to be -2, 10. All right, so the next value you can find very easily is your b value. Okay, and so the b value is that vertical distance, okay, to the vertices, all right, from your center. Not to the foci, that's C, right? To the vertices, all right? And so this is my B value. So to get from 10 to 11, you go 1. Or to get from 10 to 9, you go 1. So B is 1. Now, to find A, you got to do 2 options. You can have your equation find actually you don't have a point on this problem, so you don't have that option anymore. Your other option is to go ahead and find your C value. Okay, and so we know our C value is the distance to the foci from the center. That's a really bad bracket. Okay, so from my 10 up to my foci would be 12, or down here would be 8. So 10 to both of those is 2. So C is equal to 2. So we can go ahead and plug into Pythagorean theorem to find my A value. So you have 2 squared equals a squared plus 1 squared. So 4 equals a squared plus 1, subtract 1, and we're at 3. So a squared is 3, a is the square root of 3. When I'm thinking about this though, well, I just want to plug in a squared, right? So I'm just going to plug 3 there. All right, and so we can go ahead and write our equation now. So make sure your k goes with your y, so it's y minus 10 squared over b squared is over 1 squared, which is just 1. Okay, minus x plus 2, because we got to do a positive because it's negative, over 3 equals 1. I believe Alex will accept that. If you want to be the most correct, though, you don't really ever write divide by 1. So, ooh, I forgot my squared term. All right, and so there we go. Okay, so that's the first example, and that would be one topic. The next one is going to be a little bit weirder, okay? And so we're going to have our foci, which are at -13, 0, and 13, 0. And we will have our asymptotes, which is y equals plus or minus 2/3 x. Okay, really, really key thing here. I don't have in my asymptotes a plus k, right? So if I don't have a plus k, that means my y-intercept is 0, which means my center probably is going to be the origin. But we'll go ahead and graph it and we'll see that rather easy here, okay? So I'm gonna go ahead and just sketch a graph. We're going back 13 and right 13, right? Minus 13 and positive 13. So these are your foci, okay? So they're not part of the, they're not part of the hyperbola, but they're inside of it, right? If they're horizontal, guess what? Your hyperbola is gonna go left and right. And to find the dead center between negative 13 and 13, hopefully most of you see it right off the bat, it is the origin, okay? So our center here is going to be 0, 0. And the other thing we just talked about is this is the x minus h squared over a squared minus y minus k squared over b squared equals 1, okay? And so what we now need to do is we have our center at 0, 0. We now need to find our a and our b value. Funny thing here, though, is all I have is an asymptote. So I know for my asymptote, I go up 2 and right 3. And some of you are going, oh, but remember, isn't our asymptote just b divided by a? So is our b value 2 and our a value 3? I'd love to say that's true, and that'd be awesome. But this could be a reduced version of our b and a, right? Say b was, let's do this. What's something divided by 2? 10 over 15, right? Say it was that. Okay, we wouldn't write it as 10 over 15x. What we would write it as is 2 over 3x, right? So we don't really know what a and b are. We just know they reduce down to 2 over 3. And so things are going to get kind of weird here, but it's not too bad. What we do know is, sorry, I'm going to get a different color. Let's go here. Okay, so we do know that 2 over 3 will reduce to b over a. So the ratio of b over a is equal to that. So what I'm going to go ahead and do is I'm going to cross multiply and solve. So I have 2a equals 3b. And you got to pick what variable you want to solve for. I'm going to solve for a. So I'm going to say a is 3b over 2. All right, I hope we're doing okay so far. The only piece of information I have to work with is the distance from the foci to the center, which is c. And the only thing that I know about c is that c squared equals a squared plus b squared. Okay, so I know that that distance is 13. All right, I know my a is 3 over 2 times b. And I'm going to keep my b squared there. So I hope you kind of see what we just did. We just know that the ratio is going to be the same, right? 2 over 3 will be b over a, but b over a could not be reduced, but it will be the same. So I'm going to go ahead and write a in terms of b. You could have also written b in terms of a and plugged it in that way. Doesn't really matter. Okay, and so now what we need to do is to go ahead and solve for b, and then we can solve for a. All right, and so, this should be 13 squared. My bad. 169 equals 9 over 4b plus b squared. 9 over 4b squared. All right, and so what I really need to do is this is an imaginary 1, so 169, and that's going to become 4 over 4, so that'd be 13 over 4b squared. So I'm just kind of combining my like terms. All right, and so to get b squared by itself, I'm timesing by 4 and dividing by 13. Okay, times by 4 divided by 13. You should know that. That's just 4 times 13. It's 169 divided by 13 is just 13. Equals b squared. And so over here, I'm going to do 4 times 13, and I get 52 equals b squared. All right, so I have my b squared, essentially. B in itself is the square root of 52. Okay? And so when I'm plugging over here to a, right, I'm going to go ahead and say a is 3 times the square root of 52 over 2, which that's kind of messy, but we can leave it like that. I'm not going to, though. What I'm going to really do is a square root of 9 times square root of 52 over the square root of 4. All right, you feeling okay with what I did? I just rewrote it in terms of square roots. So that way I can now say A is this 9 times 52 divided by 4. Well, 9 times 52 divided by 4 equals 117. So A is the square root of 117, so A squared will just be 117. All right, so I hope we're doing okay right now. This is super weird, I know, and this is way different than anything we've done before. Okay, so when you're given the asymptotes, you can't just know what B and A are immediately. You know their ratio is the same, so solve for one, plug it into your Pythagorean, get another one, plug it back in kind of thing. All right, so here's the coolest thing I want to show you though, okay? We said that, some of you are looking at B and A are the square root of 52 and the square root of 117. There is no way that reduces to 2/3. No way, right? But that should be correct if that's our math, right? So I'm gonna go ahead and show you how it actually works. So B, square root of 52 over A, square root of 117. I'm going to prove to you that is 2/3. And the way we're gonna do this is we are going to simplify our square roots. And so 52 I know is divisible by 4 13 times. So this is gonna be the square root of 4 times the square root of 13. And 117 is, I believe, divisible by 9 13 times. And if you're noticing something really quick, I have a square root 13 over square root 13, and that goes away. And guess what the square root of 4 is? 2. And guess what the square root of 9 is? 3. So we did do it correctly. Our radicals do simplify. And so we are correct in saying B squared is 52, A squared is 117. Our center was at 0, 0. So we can go ahead and plug it back into this big equation. All right, we're gonna do our x minus 0 squared over A squared, which is 117, minus y minus 0 squared over our B squared, which is 52, equals 1. I'm gonna just write it like this because you don't really need to write a minus 0. And that is your answer. All right, let me know if you need another example of that topic. I know that one's kind of tricky.